Shel Winkley, thanks so much for talking to me today. Always nice when you have a friend who's also an expert on the topic that you're trying to cover, because then we get to just chat about this and I get to see you, but in a professional way as well. So thanks so much for coming on the show again today. You're familiar with Off the Radar. You've been on at least a couple of times, I feel like at
Yeah,
this point.
I think the last time we talked about old Punxsutawney Phil.
Yes, that was a
Yeah.
fun one, Groundhog Day. Okay, so let's talk about wildfire smoke because this has been a huge issue this year. And I think when it comes to stuff that's in the news, we get confused. Like, is this bigger and worse this year, or are we just hearing more about it? So that's my first question to you: are the wildfires worse this year?
So I think really let's zoom out first of all and not just look at this year, but look at 2024, 2023. It seems now that every summer we're talking about the air quality taking a hit, and especially for upper Midwest states, the Northeast, right? It's really starting to eat into our summer vacations and our summer travel plans. And the time of the year, honestly, those parts of the country, this is the time to get outside and you can't do it because of air quality. So it really comes down to where the fires are. And then, of course, the steering currents of the atmosphere. But what we know is that fire days are becoming more common, not just in the United States, but this is almost a worldwide issue. But for the focus of what we're looking at, the US and Canada. And yeah, it's impacting our air quality a lot more than it used to.
Okay, so let's go back to wildfire days because I've heard you guys say that at Climate Central. Can you describe exactly what that means? Is it just a day when something's on fire somewhere?
Yeah, so wildfire days, we're talking about not just, is something on fire? It's like thunderstorms, right? We know that there are days that can produce big thunderstorms, but the cap may hold them back and we never may actualize them. So wildfire days are days that are hot, days that have low humidity, so very dry air in place. And specifically, what's going to help spread that fire very quickly is very windy days. And what we know is with climate change, especially for the western side of the United States, which I don't think is news to anybody really, but it's really increasing for the western side of the United States. We're seeing an increase in the eastern portions of the United States. The central US is holding kind of steady, but we know that wildfire smoke doesn't have borders. So even if it's not happening in your location, that smoke can still drift into your headspace, if you.
It's almost like a tree in your neighbor's yard falling in your lot, right? So how far, though, are we talking with this spread? How far can wildfire smoke travel?
Well, it really depends on, again, the weather pattern that's at hand. So for the United States, especially if we're looking at decreased air quality, not just hazy skies, we're going to be talking about something that's either a fire that's happening in the western part of the United States or probably happening somewhere in the western or the central portions of Canada. Those are the two big areas that we see the most wildfire smoke days here locally, at least in the lower 48.
Okay, so let's talk about climate impacts of wildfire smoke because we know it affects like day-to-day weather and our health. Are there long-term climate implications when it comes to like long-lasting wildfires?
Yeah, I mean, it's the longer smoke, right? You're going to be dealing with it at a longer period, and maybe it blows out for a day because you get a storm system that comes through or a cold front that comes through, which I want to come back to that point. But then it comes back around. So it's kind of when we look at climate change, one of the big, I'm going to step aside from fires for a second and talk about heat because we know that heat waves are not only more intense and long lasting, but they're happening more frequent, which means that you may break that heat, but then it may quickly build back in beyond what is typical for summertime. So the same idea with wildfire smoke, right? Those fires don't just go out because your air quality cleared up. So when the weather pattern then switches back to a more summertime pattern, then that smoke can come back in and once again bring down the air quality. And for some of us, really bring up those health risks as well. I was talking with somebody from Minnesota the other day, and they were talking about this cold front that came in. So the wind shifted out of the north and all the wildfire smoke came in from Canada. And normally in the summertime, when you're looking at outdoor days in Minnesota, southerly winds, it brings in that humid air. You don't like to go outside. But when that wind flips around from Canada, those were the days to
Supposed
go
to be good
outside.
news. Yeah,
Yeah.
those are the good days.
And no, those are the days that you can't go outside because there's
Bummer.
so much wildfire smoke being. And when we talk about the climate change impact there as well, fires mostly are started by human activity. So it's really hard to attribute climate change to a specific fire. But we know that this is one of those, like, I think about it like speed, right? You got to keep the bus at a certain mile per hour. So this is a long-term trend. So we go from times that are very wet and the vegetation can grow, maybe probably wetter than average. But then the next year brings about very hot weather, these hot fire weather days, very dry weather. So drought builds in. So it's the underlying conditions that climate change is playing a role in here. And then when you get that right weather system, that's when you're going to see the fire spark. Now, the way that we know the recent air quality in the United States was brought a climate change fingerprint to it is because the heat that was happening in central and portions of Canada, when these fires broke out, that heat was made 4 or 5 times more likely because of climate change. That's where we can put the attribution science in. So we understand that the weather conditions were made more likely, were boosted by climate change. The fires broke out, and then the smoke poured into the US.
Okay. You talk a lot about the fingerprint and the attribution. Can you explain to people how you know that? Because I think everybody hears that a lot, like, this is climate change. It's definitely made worse by climate change. But what's the science behind that? How do we know?
Yeah, attribution science is interesting because we went for so long really not able to say one weather event or the other was made or made not by climate change, right? We had to look at those long-term trends. So now what we can do with attribution science is essentially take our modeling, right? And so the way we do it with temperatures is we have over 20 models that we run, and we run it in 2 ways. One, with all the historical emissions of greenhouse gases that we've pumped into the atmosphere, which we have a very detailed record of. And then we run it again without those gases. So in a stable climate that we didn't burn heat trapping pollution. And you get a ratio. And for us, we use a tool called the Climate Shift Index. It's a scale of 0 to 5. And a 5, it doesn't necessarily mean that the temperature is absolutely impossible, but would be almost virtually impossible without the influence of climate change. So we're talking about 90-degree days or more in central Canada, right? Not completely unheard of, but they're happening more frequently, and that's adding to the drought. So when you put it all together, that's how we understand that climate change doesn't play the whole picture, but it is at least part of the picture when it comes to this fire danger.
Okay. So the future is scary and everything is bleak. What about in the short term? What is wildfire season like? When are things gonna wrap up here as we're finishing up August? Is there an end in sight?
So yeah,
Are you gonna tell me the season's longer now too, Shel?
the season is now longer. And if you look at the latest forecast that came out for this wildfire season, the year started earlier. It started with the fires in California around LA, and just looking into the future at weather patterns and then the conditions of the fuel sources, the vegetation that's in place. Yeah, fire season again this year is expected to last longer into the fall season. And that's specifically for the West. So what we know just using the long-term trends is that the West has added anywhere from 25 to 55 days on average per year that have these quote unquote fire weather days. So again, that doesn't mean 25 to 55 days that you will have a fire that absolutely will start, but that's 25 to 55 more days per year that we have to monitor the weather closely, and that we have to make sure that we're doing the things that we can do to our best ability as to not set off a small spark that then can create a flame that can then be pushed across dry vegetation and turn into one of these large wildfires.
Okay. All right. Well, thanks, Debbie, for that. Other than don't start a fire, what else can we do?
One, the most basic thing that we can do, and it will take a long time to reverse, but is to stop pumping heat trapping pollution into our atmosphere, right? We have to bring down the coal, oil, and methane gas burning, and we have to supply it in our energy sector with renewable energies and electric vehicles. That's really hard. That's a long-term solution that we have to work on together. In the meantime, the things that we can do if you're in a fire susceptible area, think about what is native to your neighborhood, native to your city and your community. Put those native plants back into your garden. And then again, just being overly aware. These big fire weather days, I think a lot of people are very aware, but know what you can do to protect your house, right? Bring that vegetation maybe a little bit further from your house line. What we're doing right now, Emily, is a solution. Conversation and communication is a climate solution. So go to your neighborhood, go on a block party, go to a city council meeting, right? And bring these up. Bring the fact up that we know that these days are getting longer when it comes to the calendar. And what can we do to implement in our community so that we can maybe mitigate that fire risk for even these days that are quote unquote the fire weather days?
Cool. Where can we find information, super local information about our communities and what the air quality is and what the fire weather days may be like?
Yes. So a couple different places. One, your local meteorologist, your local weather person. If you have one of these big days that's going to impact your air quality, they're going to let you know about it. There's a great airnow.gov is going to be a great site for you as well. When it comes to the climate change aspect, and if you really want to dive in, what we did is we broke it down by climate divisions across the United States. And so you can find the localized data for how many days fire weather has increased. For some of us, it's just a couple days on average. For others, like I said, 25 to 55 or more. That's up right now at climatecentral.org. And very soon, we're going to have a new analysis that really looks at these smoky days so we can understand on average how many more wildfire smoke days you're encountering in your neighborhood, in your city, than maybe you did back, say, 50 or 60 years ago.
Shel, Winkley, is there anything else you want to add about Climate Central or air quality or wildfires?
Just remember what our old friend Smokey Bear once told us. Only you can prevent forest fires, and only you can prevent climate change. We just have to work on it together. And again, I'll stress that conversation and communication is a solution. That is the first step that you can take.
Well, awesome. Thank you for sharing that information with us today.
Yeah, thanks for having us.
So let's talk about how we rate air quality. Is there a system for this, and how to help us understand how this is rated and how we can understand what the threat is?
Yeah, so the air quality index, just the AQI, there are 6 kind of categories. There's green, which is good. There's moderate, which is yellow. Unhealthy for sensitive groups, that's the orange AQI kind of color. There's unhealthy, that's red. Very unhealthy, that's purple. And then hazardous is maroon. So there's different categories or ratings for each of those. Basically, nationwide for air quality meteorologists, we use the orange AQI, the unhealthy for sensitive groups range, as kind of the threshold for issuing an air quality advisory, air quality alert, air quality action day. There's different verbiage across the US. Specifically here for us in Michigan, we have an air quality advisory system and air quality alert system, whereas the advisory system is more so just for the unhealthy for sensitive groups range. That's for people who are more sensitive to air pollution, like as other underlying respiratory illnesses, elderly people, sometimes young kids. And then once we get into the unhealthy or worse range, that gets into the alert level, which brings in the general public. It could be the most healthy person, but you'll feel some impacts from wildfire smoke or just air pollution when it gets to that level. Across the Midwest and across, like I said, the nation, they have different setups. But for the most part, inconsistently across the US, we use the orange AQI as the threshold for issuing some kind of alert, alerting people that the air quality is poor.
Okay, so tell me about the communication side of things. Do you work with the National Weather Service for like folks who maybe aren't staying up to date on the news or don't have an app on their phone to track air quality? How will they know if this is happening?
Yeah, so going back to like just nationwide, I'm pretty sure nationwide, any state that has air quality meteorologists within their state government, they issue the alerts, at least here in Michigan and our counterparts in Minnesota, Wisconsin, the Great Lakes kind of region. We issue those advisories and alerts, and we contact our local National Weather Service offices to tell them, here's what we're thinking. Can you just put this out on your interwebs, your products out? Because they obviously have a bigger footprint than us. So that's how it gets to like the Weather Channel app, Apple Air Weather, all that fun stuff. That's how the TV meteorologists, they see it on and broadcast on TV because it comes from the National Weather Service. I'm here in Michigan, and from what I know, across the Midwest, our offices basically just take our forecast and our issuance, just basically copy paste into their product. So it says Michigan Department of Environment, Great Lakes and Energy has issued an air quality advisory for so on and so forth. So that communication is pretty, it's a direct link. We're actually setting up a communication kind of meeting with our offices later in September just to kind of fine tune the communication, kind of get timing more down, just so it's more streamlined and more fluid.
Gotcha. Okay, and this may not be specific to wildfire smoke, but when it comes to air quality, are there certain weather features that may make an air quality situation better or worse on a particular day, like a hot and humid day? Is that going to be lower air quality, or does it just feel like it is?
Sometimes, yeah. For smoke, it could be hot, cold, doesn't really matter. It just depends on the wind speed. Obviously, hotter weather, more stormy weather, that can spur up some more wildfires, drought conditions, obviously. But I guess more so too, what you're asking, we forecast both PM 2.5 wildfire smoke. That's kind of just the umbrella term for wildfire smoke. There's dust and every other particulate involved with there. But we also forecast surface level ozone. That's even more weather dependent than PM2.5 because for a typical ozone day here in Michigan, we like to look for, and across the Midwest as well, because Lake Michigan plays a big role in this. We like to look for days that are 80 plus degrees Fahrenheit. Dew points around 55 to 65. We have been noticing, there's not many studies on it yet. We have been noticing when dew points get higher in the really muggy range, there's not much ozone that produces. We're not sure the chemistry that happens with the chemical reaction. It could be that the air is just so muggy and soupy, it's kind of weighing down the pollutants in the air. Or it could be there's a lot of water droplets within the air, the moisture, the humidity, so it's kind of the UV rays and sunlight are kind of scattering and producing the ozone chemical reaction. Because my next point, ozone is an atmospheric chemical reaction that occurs within the atmosphere. It needs VOCs, volatile organic compounds, NO2 kind of oxides, to basically create O3, which is ozone. So in the more industrial areas like Detroit, Chicago, Gary, Indiana, those are kind of the ozone hotspots when the weather conditions get to the 80 plus degree temperatures. You need ample sunlight. If you get a light breeze, a southwest breeze, it kind of blows all of those pollutants and ozone plume into our southern Michigan areas. So with ozone, it's a little not easier to predict, but you can see it further out by saying, okay, next Thursday, we're looking to have a setup where we're going to be having 80 plus degrees, sunny as of now, and then the southwest wind. So we're kind of anticipating it more. Whereas with wildfire smoke, it just depends on the wind speeds and the wind direction, which can kind of change on a dime. Prevailing weather patterns, it can be obviously seen a couple days to a week out.
What's your educational background? Because your knowledge of atmospheric physics is much greater than the typical undergraduate requirement courses.
I just have a meteorology degree from Central Michigan University, and a lot of this is just picked up on the fly from my two other coworkers, meteorologists here in Michigan, who have been here a lot longer. So I'm just a sponge, just absorbing that stuff.
Gotcha. Okay. So let's talk about staying safe and what we can do to stay safe. Because I have, there's a lot of kind of scary articles out there about this is equivalent to smoking a certain number of packs of cigarettes a day. Well, that's scary because we spend our whole lives, avoiding that and telling our kids to avoid that. So what can we do to stay safe?
So on the onset or after the first big wildfire episode we had back in 2023, after that season was done and it got into more of the fall winter season, we decided to talk to our health department here in Michigan because they're contacting us throughout that entire summer, having us give them heads up and everything just because they wanted to put on their channels and their more localized health departments across the state. So we said, yes, please give us information that we can include into our messaging as well. So we put on a forecast to provide tips to people to protect themselves. So they came up with saying, if you are more sensitive to air pollution, try to stay inside if you can. More so with wildfire smoke. If you can, close your windows. If you have a central air system, run it with a good MERV 13 or more filter, just kind of filter out those particulates. Because wildfire smoke obviously can come into your house. Whereas ozone specifically, that needs sunlight to survive and UV radiation. As soon as you get to your threshold of your house in the shade, it can't survive. Whereas wildfire smoke doesn't matter. It can just be blown into your house. Okay. So they also have recommendations if you have to work outside, if you need to be outside. I like to say just trust your body. If you notice your sinuses are acting up, whereas you don't have allergies, underlying allergies, if your eyes are getting watery, your nose is getting stuffy, that's your body telling you that it's getting impacted by the wildfire smoke or just air pollution. So they started recommending the N95 or K95 masks if you want to, but it's more so just on a person-to-person, basis-to-basis level. Trust your body, and then we just provide those tips with our forecasts, and they provide it as well on their website and to their more localized health departments.
Does it matter what's on fire? Like, I'm picturing like this stuff going into your lungs, like a wildfire where it's trees and brush versus like if homes are on fire and like synthetic things are just floating around in the air and you're inhaling them. Do you know, is that worse?
Yeah, so actually, we had a lot of questions with TV interviews back in 2023, like why people were saying it smells weird, it smells like burning plastic. So we talked with our toxicologists in house, and they were doing some research, asking around, and I heard back from EPA saying that yeah, it does matter. They don't really know the correct answer for it yet, but it does matter if it's burning just straight up biomass, trees, natural, or if it's going through an industrial area or houses or something. Obviously, there's more chemicals involved there, so there's a different smoke makeup. But also with biomass, just burning more natural stuff in that area. For the most part, that smoke is in the atmosphere for hundreds of miles a lot of times. So it's going through its own kind of atmospheric chemical reaction, interacting with different weather patterns, different air masses, and everything. So it's kind of hard to pinpoint what exactly is within the smoke, but there is a difference. I actually had a conversation with our toxicologist yesterday, and she was saying the PM2.5 monitors we have across the state are it's a good network just to pick up, and across the region, a good network to see what the concentrations are. But the more specific kind of toxins, VOC kind of monitors are not as dense across the region. So if you're in the northern part of Minnesota, the smoke's going to be different than the smoke down here in southern Michigan. So it's just kind of hard to kind of pinpoint what exactly is in there. But per EPA, there are differences, just not exactly known what's in between what is actually burning.
If we don't know where to look for alerts, where can people go to look for this information?
So I always like to point out each state has their own kind of monitoring network, like I said, for air quality or air pollution, but it all is sent to EPA. So airnow.gov is EPA's official air quality interactive map website. So I always like to point that out. It shows both PM2.5 and ozone, which are the big pollutants that we forecast across the nation. It also just has generic AQI, which includes carbon monoxide, nitrogen dioxide, a bunch of other kind of big criteria pollutants that they look at. So that just gives a great overview of where you're at. But for the specific alerts and advisories, I'd say just pay attention to your weather app and include notifications from those. I believe they're pretty specified. You can click which ones you want to have on or off.
Aside from wildfire smoke, just when it comes to air quality in general, I don't want to ask you to throw anybody under the bus, but like, what do you see as parts of the country that are like really great air quality spots, and then some that are like kind of on the naughty list?
Aside from obviously these wildfires, more north you are, because there's not a lot of industry up there. Like I mentioned with ozone, it's a pretty known kind of common knowledge that in the Great Lakes region and kind of across the nation, there's a lot of transport issue with ozone and those pollutants. Like I said, with Chicago and Gary, Indiana, and the southern basin of Lake Michigan for us specifically, because in southern and western Michigan, there's not a lot of industry aside from Grand Rapids area, the big city over there. But the more southwest corner of Michigan, and a good ozone day is setting up, we see a lot of ozone. It's all being blown across Lake Michigan. My senior meteorologist likes to say that the southern Lake Michigan basin kind of acts like a double bake oven, because those pollutants just blow over the lake, sit there for a day or two. If it's a clear day, those UV rays come through the ozone plume, hit the lake, and it acts like a mirror. It bounces back through the plume, and it kind of just double bakes the plume, because we see a lot of ozone producing over Lake Michigan just based on the models we use and forecasts. And like I said, when we get a southwest wind, it just blows all of that stuff into southwest Michigan. So that area for us it's known. We know about it. There's a lot of stuff going on, studying it and what we all can do to kind of help the overall region. But then, of course, you have just a smog and ozone issue out west, and more like just the populated areas. They always tend to have ozone issues. But with those areas and those hotspots, there's always a lot of research going on. EPA is doing a lot of this mobile sourcing kind of data collecting, just to overall just get a better idea of what's going on and how we can help to improve it.
We know how weather affects wildfire smoke. Does wildfire smoke affect weather? Does it keep afternoon temperatures a little lower?
I'd say yes, because actually our local TV meteorologist, he was actually saying that he just kind of mentioned that we were having days forecasted to be in the mid 80s, but they stayed more so in the lower 80s because, yeah, a wildfire smoke kind of acts as like a pseudo cloud and actually interacts with ozone because, like I said, it needs a lot of UV radiation. And so there'd be a day that we would expect ozone to produce, but then there's too much upper level smoke, so it just kind of blocks out that radiation rather a little bit, so it just doesn't produce ozone. So it does kind of act like a pseudo cloud and can kind of blanket us and kind of keep the temperatures cooler in the afternoon.